Hola Bayo, today I'm going to show how to solve a problem in fluid flow measurement. So here I have a problem. A venturimeter is fitted in a pipe of 30 cm diameter inclined at 40 degrees to the horizontal to measure the flow rate of petrol having a specific gravity of 0.8. The ratio of areas of main pipe and the throat is 5 and the throat is at 1 meter from the inlet along its length. The difference in manometer head is 40 mm of mercury. Assuming the coefficient of discharge as 0.96. Calculate the discharge through the venturimeter and the pressure difference between the throat and the entry point of venturimeter. So this is the figure. So we're going to look for discharge through the venturimeter and the pressure difference between the throat and the entry point of venturimeter. So the equation for discharge is Q is equal to coefficient of discharge times area sub 1 area sub 2 over square root of area sub 1 power of 2 minus area sub 2 power of 2 times square root of 2 times gravity times height times density of mercury over density of petrol minus 1. Since our area sub 1 and area sub 2 is unknown, we're going to look for it. So the equation for area sub 1 is pi over 4 times 0.3 power of 2. This 0.3 came from 30 centimeter diameter converted into meter. So our area sub 1 is 0.0707 meter squared. The equation for area sub 2 is area sub 1 over area sub 2 is equal to 5. Then area sub 2 is equal to area sub 1 over 5. Since we already have the value of area sub 1, we're going to put it. So area sub 2 is equal to 0.0707 over 5. So our area sub 2 is 0.0141 meter squared. Since we already have the area sub 1 and area sub 2, we're going to look or we're going to find the discharge through the venturimeter. The value of coefficient of discharge is 0.96 times the area 2 sub 2, then the area sub 1. So the area sub 2 is 0.0141 times 0.0707 over square root of 0.0707 squared, the area 1 minus the area 2, 0.0141 squared times square root of 2 times 9.81 times the height, which is 40 millimeter of mercury converted into meter, which is 0.04, times the density of mercury, which is 13.6, and for petrol is 0.8 minus 1. So our discharge is 0.0486 cubic meter per second. Since we already find the discharge, we're going to find the pressure difference between the throat and the entry point of the venturimeter. So the equation for that is P sub A minus P sub B is equal to density times gravity times x plus 0.04 times gravity times density of mercury minus density of petrol. So since we have the incline at 40 degrees in vertical, we're going to input that. So this is the equation is density times gravity times 1 times sine 40 since vertical plus 0.04 times 9.81 times 13600, which is the density of mercury minus 800. So the answer for that is, we're going to input them all. So 800 times 9.81 times 1 times sine 40 plus 0.04 times 9.81 times 13,600 minus 800. This 800 density came from the specific gravity of 0.8 of petrol times the density water, which is 1000, so 800. So our pressure difference between the throat and the entry point of venturimeter is 10,067.32 Newton per meter squared or 10.707 kilonewton per meter squared. Thank you for listening and have a great day.